Hello and welcome. In this video I'm introducing the least squares moving average encoded in Python. Someone of you proposed this, so thank you very much. I think it's tailored content for this channel. It's a bit of statistics or data science in combination with trading, so definitely stay tuned and don't even think about skipping a single second of this video. So how does it work in a nutshell? You're running an OLS regression, ordinary least squares regression, for a certain window or lookback. Let's say 25 days. Your independent variable is the day, so day 0, day 1, day 2 and so on. Your dependent variable is the close price. This is how you're running a simple linear regression in the stock market in general, and it does make sense when you think about it. You want to know what the stock is worth at day X, so maybe tomorrow, maybe in 3 days and so on. So for the least squares moving average, LSMA, you need a prediction for each day based on this regression over the past n, so in our example 25 days. And to be clear here, if you have 600 rows or 600 days of data, you need to run 600 regressions. So this is the main concept, but I'm trying my best to explain this as in-depth as possible while coding. Alright, let's get started. We need some libraries. Why finance suppose stock prices from the internet? Pandas for data handling. For the linear regression, I'm working with stats models. You can also take sklearn. And for visualization purposes, I'm also importing matplotlib. Next, we are going to pull stock price data for, let's just take Apple, and we are starting in the beginning of 2020. Ending up with a data frame like this containing open, high, low, close data. Just as a side note, in this video I'm working with the close column. The 100% correct way would be to take the adjusted close column. Now, in the first step, I'm going to show you how to run the regression for the very first row. So only for a single row here in this data frame. Our window, as said in the beginning, is 25. So we need to run a regression over the first 25 rows of this data frame, right? So what we're going to do, we are creating a test data frame, and this is just sliced for the first 25 rows. So this is looking like this, has 25 rows. And it's going until the 5th of February here, right? So this is a data frame with 25 rows here. And the first value for our LSMA value would be for the 5th February. So this last row here. So let's create the linear regression. So first of all, for the linear regression, we need to define our dependent variable. And I'm just calling that y underscore. And my y underscore is simply my close column, as explained in the very beginning. So this is simply my dependent variable. My independent variable is my date, but not in a datetime format, but in an integer format. So what do we mean by integer format? I want to have this date as day 0, day 1, day 2, day 3, and so on. So I'm simply transforming the dates into integer values. And I can do that by using PD series and then simply take the length of the test df index, which is 25, and then just pull a range, so I'm just getting values from 0 to 25 if I'm wrapping that into a series here. So if I'm doing that like so, you will see that I'm just getting 0 to 24, right? So 25 values here. So we have this, and as you see, this has an index, so I just want to have those values here. So I'm just taking values. With that, I'm getting 0 to 24 and have everything what I need for my independent variable. And I'm calling that x underscore. This is my independent variable. Important here is, if you're working with stat models, the intercept is not included by default, so you have to add an intercept. So I'm going to define a model here, use SM ordinary least squares regression, provide my dependent variable and my independent variable, but have to add a constant to that to get an intercept. And I also want to fit my model. Of course, provide the right variable name here and here as well. And with that, I have my model, and my model has certain parameters. So as you see, we have an intercept of 75 something and a slope of 0.22 something. And now, what do I do with that? I need a prediction. My very first prediction is for this date here, right? For the 5th of February. And this is row 24. So 24 because just the simple zero indexing. So indexing in Python starts at 0. So this is my 25th rows, but technically it's my 24th row here, right? So the prediction using the linear regression would be my intercept plus my independent variable value, which would be 24, as said, because this is technically row 24, times my slope, right? So just as a recap, this is the formula. So you have the slope times your independent variable plus the intercept. So if I'm executing this, I'm getting my predicted value for row 25, technically row 24. So you can also get this value to make things easier by just using the model's predicted values and then screen for the very last value here. And this is how I'm going to do that when doing the loop later on, because it's easier than constructing this equation here all the time. So this value is exactly this value, and how is it calculated, as I just explained, by using this formula, taking the model's parameters. So just to make this really clear, if I'm taking 0 here, I would get this value, right? But we are not interested in that value at all. We are always only interested in this value, because this is the value for, so this is the predicted value for the last row, which we need. So I can simply screen for the last value here, and I'm getting the predicted value. And this is, as said, the value for the very first row we can work with using the LSMA. So this is the value for this row. The rows before, we cannot have any values because we have a 25-day look back. So the very first one would be this row here. This is important to understand. And now what we are going to do is we are doing exactly what I did for every single row after this row. And how will this work? We are slicing the data frame like so, but we are going one row every single time. So the next regression would be from this row on until one row after this one, so 6th of February, right? So we are slicing the data frame and we are incrementing both the starting value and the ending value by 1. Okay, and this is what I'm doing in the next step. So this is important to understand that you got this all, because this is what I will use in the loop now. So I'm creating 2 arrays here. First one is my LSMA array, where I store the LSMA values. So in the very first row, this is my LSMA value. I'm also storing the dates. And what I'm going to do here, this is simply for data handling reasons. So this is the only reason I'm doing that. I'm storing the date of the very last row of the sliced data frames so that I can map the LSMA value to a date. So for the first case, this would be this date. This is the date for the first iteration, and this is the LSMA value for the first iteration. And now I'm looping over the data frame. So for I in range length of the data frame, but I have to subtract 24 here. Why? Because if you take a look at the data frame and the shape, it has 715 rows, but you're starting at the 5th February, right? At this row here. And if you take a look at that, that would be from this row on here, right? And these are 691 rows. So if I'm subtracting the 24 from that, I would get 691 rows, which are the exact number of my iterations. So from this row on, I'm creating LSMA values. And as I explained, I'm going one row and increment the starting value and the ending value and run a regression in every single iteration. So I'm running 691 regressions in this case. So limit the loop here. And now I'm going to create a data frame. This is the sliced data frame, and I'm just calling that input for the regression. And this is slicing our data frame going from I, so 0 in the first iteration, because we are starting at the very first row in the first iteration, as I did here, right? So I was slicing the data frame, test data frame, and this is the very first row. This is row 0. And I'm going until row 25. So why 25? Because when slicing, the last value is always excluded, right? So just as a recap, if I'm doing 0 to 24, I'm not going until the 5th of February, but 4th. So I have to go until the 25 value, because the slicing value, so the value where you slice to, is always excluded, right? So it is technically right to slice it for until row 25 here. And with that, I'm getting my 25 rows here. So this is, for the first iteration, it makes sense, right? 0 to 25, I just showed you. Plus I here, because I want to go in the second iteration from row 1 until row 26 to get the next slice of the data frame. Next iteration, row 2 until row 27, and so on. So this is what this slicing here is doing. It is simply creating an input for the regression we need. And then we define the independent variable. And I'm just taking the same logic as before, creating a series of the range of the length of this input regressions index. And then take the values. So this is always the same, right? This is always 0 to 24. You can also keep that static, but I think that's a more intuitive way to show it. Then the depend variable is simply my input regression and then the close column. And finally, I'm going to define the model using an ordinary least squares regression, provide my depend variable, and add a constant to my independent variable, and afterwards fit the model. Then I have a prediction. As explained, I'm simply taking the last element of the prediction array. So I'm using model predicts and get the last value here. So this is the same as I did here. And finally, I'm just going to append to my LSMA array and also to my dates array to get the the date where this prediction is mapped to. So I'm simply taking the input regression and screen for the very last row here, and then the name of that row, which is the date. So just to make this clear, if you take a look at the test data frame, if we're taking the last row here, the name here is the 5th February. So if I'm screening for the name, I'm getting the timestamp here. So this is how it's working. And with that, so with running this loop, we have our LSMA values here. And with the dates, we are creating a data frame out of that. So I'm just calling that LSMA data frame. Use pandas data frame function. Provide the column name LSMA, provide the LSMA array for that, and set the index to our dates array. And with that, we're getting this beautiful data frame containing our LSMA values, right? And we want to bring this data frame together with our initial data frame, so this one here. We can do that by simply, I'm calling that all data frames, so this is just the data frame, this data frame merged with this data frame, and I'm using pd concat for that. Provide my LSMA data frame and my data frame, and define the axes as 1. And with that, I'm getting a merged data frame containing the LSMA column and the other columns here. Okay, so of course the first 25 rows, or the first 24 rows contain NaN values. The 25th row will contain the first LSMA value, right? So if we're taking a look at the head here, you will see, as shown in the beginning, first value is at the 5th February here, okay? So maybe we can just get rid of the NaN values here. So we got our data frame. And now let's create a very simple strategy so we can create more dedicated strategies combined with other indicators in the future. If you're interested in that, just let me know below. So for now, I'm just taking a very simple strategy. I'm creating a buying signal when the close is below the LSMA value, and the selling signal when the close is above the LSMA value. So all df signal buy is all df close is below all df LSMA, and vice versa for the sell, all df close larger. And when I'm getting a signal I want to buy, I will show you here. So imagine I'm getting a signal here, then to avoid a forward-looking bias, I can only buy on the next day's open here. I can buy for this price here when I'm getting the signal. So for that, I'm simply shifting the open values 1 row back, so I get the right buy price in my row where my signal is true. So I'm calling that shifted open, all df open shift -1. And as I just said, so for this, when I'm getting a buying signal here, I know I can buy for this price here, and I have the price stored in the same row now. And now let's iterate. So I'm setting the initial position to false. This is my Boolean, which is containing if I'm in a position or not. And then I'm creating some empty lists here, buy dates, sell dates, which I will populate. And also buy prices and sell prices. And now I'm just simply looping for index row in all df iteros. And if I'm not in a position, if not in position, and I have a true value in the signal buy column here, so row signal buy is true, then I want to buy. And my buy price, as explained, is simply my shifted open. My buy dates is the index. I'm appending to my buy prices. So I'm just simply taking the buy price here. So maybe let's structure that a bit more logical. So after defining the buy price, I will append it to my list, then append the buy date. And in the end, I'm setting my in position value to true because then I'm in a position. And if I'm in a position, so this is the selling condition, and my row signal sell value is true, then I want to sell. So my sell price is again the next open. Sell prices, append the index, and then no, of course not. Sell prices, append the sell price, and then sell dates, append the index, and when I sold, I'm not in a position anymore. So very straightforward strategy, right? Very simplified. So let's run this loop, and with that we have our some populated lists, buy dates, sell dates, and also buy prices, sell prices. So to calculate the profit, I'm just taking the sell prices, subtract the buy prices, and set that into relation to the buy price. And with that, I have my relative profit, doing that within a list comprehension here. So sell minus buy in relation to the buy for sell buy in sell prices, buy prices. So we have our profits for each trade, wrap that into a series, store that as profits, and take a look at our overall profit by taking the products out of the returns. And we made some nice profit here, right? 105%. So yeah, kind of a coincidence here, but or maybe a coincidence, who knows. But let's visualize the strategy for now. So setting up a figure here. But I've covered that so many times, I'm going to copy paste that from my other screen here. So quick explanation. Figure size is making the plot larger. Then I'm taking a look at the open price and the LSMA. You can also plot the close price, but we are buying on the open. So to get the selling and buying signals properly on the graph, I'm plotting the open here. Then I'm taking the scatter plot, take the x-axis as the buy dates and the y-axis simply as the open or the shifted open price, and same for the sell dates. And with that, I'm getting a figure like this containing my buying and selling signals to get my strategy visualized. So the blue line here is the open, and the orange line here is the LSMA. Okay, so finally, let's take a look at the win rate to make this complete. So value counts. So we have, what is it? We're win rate of 68% here. Yeah, but also you see that this is a rising asset, right? So let's actually check if we outperformed the asset. So we could take a look at this price here in the very beginning, set that into relation to the last price, and have the assets return. Of course, don't do this mindless stuff, do it the other way around. And Apple was rising by 90%. With this strategy, we would have made 105%, but this is without trading costs, right? So yeah, this is a brief introduction to that. I hope this was interesting. I would like to explore the strategy a bit. So combine it with other indicators, build up a more sophisticated strategy, test it on cryptos and stuff. So if you're interested in that, leave a like comment. And yeah, thank you very much for watching, and I'm looking forward to see you in the upcoming videos. Bye bye.